Hey everybody, welcome back. Apologia, 8th grade physical science. Today is week 3, day 3. Textbook pages 41 through 47, notebook pages 43 through 47. We are starting module 2. We will discuss classifying matter, properties of matter, and changes in matter, which kind of just leads to the big question. So what is matter? Matter is anything that has mass and takes up space, volume. Matter makes up everything. We can't see what matter is made of, but we know it has mass and volume. Classifying matter. The pen that we are writing with is made of matter. The notebook that you are writing in is made up of matter. The chair you are sitting in is made up of matter. The desk you are sitting at is made up of matter. You are made up of matter. We can visually see that they are made up of different kinds of matter. We can recognize the differences between the various types of matter based on their properties. On page 44 in our notebook, we need to fill in some of these words, and then we can define some of these words. Characteristics that describe how one kind of matter is different from another is called the matter's properties. In science, each kind of matter is called a substance, which has a unique properties because of its unique composition, and it is organized into groups in a process called classifications. One important way to classify matter is as either a pure substance or a mixture. Matter that cannot be separated into any other substance and always has exactly the same composition is classified as a pure substance. A mixture contains two or more substances. Sugar is an example of a pure substance, and sweet tea is an example of a mixture. A pure substance will always have exactly the same composition. Pure substances can further be classified into two categories. They can either be an element composed of only one type of atom, or a compound composed of two or more types of atoms. So again, an element is one type of atom. It's a pure substance with one type of atom. A compound is composed of two or more types of atoms. An element is a pure substance that cannot be broken down into a simpler substance. If you could cut a gold ring into smaller and smaller pieces, eventually you would end up with one teeny tiny gold atom. Sugar is another example of a pure substance. However, it is composed of three elements: carbon, hydrogen, and oxygen. So how can you tell if it's a pure substance? Well, for one thing, each spoonful of sugar tastes equally sweet. Also, no matter how small a granule of sugar you have, it will always have the same composition: carbon, hydrogen, and oxygen in the same ratio as every other granule of sugar. Sugar is an example of a compound. And remember, a compound is a pure substance containing two or more elements chemically bonded in fixed proportion. A molecule. Let's talk about water. Water is another example of a compound. Water is composed of two elements, hydrogen and oxygen, chemically bonded together. Each molecule of water will always have two atoms of hydrogen and one atom of oxygen in that fixed proportion. So a molecule is the smallest unit of a chemical compound composed of two or more atoms bonded together. Mixtures, moving on. Like compounds, mixtures are composed of two or more substances, but unlike a compound, a mixture can vary in the proportion of its components because they are not chemically bonded together. So the definition of a mixture is two or more substances mixed together but not chemically bonded. Mixtures may consist of elements, compounds, or both. Scientists classify mixtures by how well the substances making up the mixtures are distributed throughout the mixture. Sometimes in a mixture of two or more substances, both substances remain visible. For example, if you mix sand into a glass of water, both the sand and the water can be seen. When the parts of a mixture are noticeably different from one another, the mixture is classified as a heterogeneous mixture. The term heterogeneous comes from two Greek words, hetero meaning different and genus meaning kind. If you think again about our cup of sweet tea, you notice the caramel-colored water. Since we're told that it's sweet tea, we know it is a mixture of tea, water, and sugar. However, we can't see any of those individual substances. This type of mixture is classified as a homogeneous mixture. Homo is the Greek word meaning same. A homogeneous mixture appears to contain only type of substances because the substances are so evenly distributed that it is difficult to distinguish one substance in the mixture from another. All right, a solution. A solution is a homogeneous mixture made by dissolving one substance in another. The most common solutions are mixtures of water with something else. The substance that's dissolved in this is the solute. The substance which does the dissolving is the solvent. So again, the solute is the substance in a solution that gets dissolved. The solvent is the substance in a solution in which the solute dissolves. In our sugar water solution, water is the solvent and sugar is the solute. All right, finishing up. On your own, 2.1. What are pure substances? Why does every sample of a pure substance have the same properties? Pure substances are substances that have a fixed composition. They can be either elements or compounds. A pure substance always has the same properties because its composition never changes. On your own, 2.2. Why can the properties of a mixture vary? And give an example. Properties of mixtures can vary because the composition of a mixture is not fixed. Sweet tea is an example. The more sugar you will add will cause the tea to taste sweeter. And lastly, on your own, 2.3, if you add salt to your hot tea instead of sugar, how would this change the properties of the tea? What kind of mixture would that be? If salt was added to tea instead of sugar, so again, if salt was added to tea instead of sugar, the tea would be salty instead of sweet. The salt tea is a homogeneous mixture, also known as a solution. All right, everybody. See you tomorrow with week 3, day 4.